Thanks a lot to Franz, and now we'll move from strategy to real-world use cases. Our next talk is on use cases and on business outcomes, and is trying to answer the question, what we really mean when we're talking about quantum advantage. So what it actually means will be showcased by using two examples from production and from telecommunication, and I'm really happy to introduce a joint presentation with the title Quantum and Optimization in Business, Applied Technology in Manufacturing and Telecommunication. And on stage are our two speakers, Oliver Holschke, he's architect in Future Networks and AI program at the Telekom Innovation Laboratories, and Georg Huben, who is the business development and partner management manager for connected services at our partner company, Fujitsu. Let's dive into it. Have fun. The stage is yours.
Thank you, Kim. Great to be here. Thanks for the introduction. And as Kim already mentioned, I'm business development and partner management on our quantum-inspired optimization services, and I'm very happy to have a partner today with us. So it's Oliver from Deutsche Telekom T-Labs.
Hello, great to be here.
Okay, so when the usual challenge that we see when it comes to business in quantum and optimization services, how do we tackle that? How do we approach that? And for this, we at Fujitsu want to engage with our partners and our customers in a three-stage approach. This is shown here with an initial workshop, first of all, because we need to identify use cases and we need to find reasonable ways to deploy quantum and quantum optimization services. And once we have done that with customers and partners, we usually jump into proof of concept, proof of value. But this is in a very agile way. We have to understand the initial direction might not be the one that we finally conclude. We need to adjust direction before we finally come to the commercial use. And it's always important to have this stage approach in order to make sure that the partners working together understand each other, know what they can do and how they can cooperate. This will finally result in successful commercial use. But wait a minute, quantum and commercial use, isn't that something which is quite some time away? So let me give a brief introduction on what we are doing in that stage. So, oops, apologize. We do not have straight quantum technology. We have what I call the quantum-inspired optimization services, which is basically a special chip designed in traditional CMOS technology, which is specially designed for combinatorial optimization problems. And for those familiar with this terminology, you see the solving the energy function that can be described in such a mathematical way. Sounds a bit abstract, but usual problems like traveling salesman and so on can be shown in this one. And with our specific design, we can work at room temperature because we have standard CMOS technology underneath. It is quantum inspired, and therefore we can be very fast for these specific solutions. As an example, why I try to reduce my introduction of the digital annealer to 1 minute. In this 1 minute, the digital annealer could compute optimization for a problem that a usual computer would need 166 hours. So that's the type of speed improvement that we have with this technology. And that is what we want to apply because we will have quantum computers in the real world with the real world scenarios in the future. But we have some topics to tackle now when we look into the deployment and the use cases. Talking about use cases, as I said, for the initial alignment with our partner, with our friends from T-Labs, we met together in that initial workshop. We tried to figure out what are promising use cases that we can use. And we found, among others, this mixed sigma case which is about a manufacturing situation. I'm in our manufacturing and automotive organization, so that's my home turf to some extent. Just brief description. We have a headlamp here shown on the picture. There is a reflector, which is the part number 1. We have the lens, part number 4. And those two parts are manufactured in a production in 2 different production lines. And at the end, they are combined, and then they have to be mounted together. Now, each part does have some tolerance. And if you think of the allowance here for the reflector, 1.0 is the norm, 1.06 is a deviation in the manufacturing to one extent, and 0.99 is a deviation in another direction. And important is, what is the result? So do we still meet the specs for the light refraction that is to be achieved by the whole system? In that example case, we took the allowances for both components, and we did the average of both on the right-hand side here. And this has to be in a certain scale, so 1.025 and 0.975 are in spec, while any further deviation is not allowed. Now, if we take the first part, combine it with the first part, with the first reflector, combine it with the first lens, we come up to 1.035, which is too much, and therefore this part has to be trashed. The next 3 ones are okay, and when it comes to the 5th one, we still have that issue. So that's straightforward, and the challenge in the Mix Sigma problem is, can we reduce the amount of topics, of items we have to trash by changing the order? As you can see, when we combine the first and the first and second and the second, we have 3 parts, and it's easy to see here that if we change the order a bit, so changing first and second part, 4th and 5th part, then we can use all of that. We don't have to trash anything. So that's the use case that we had. Doesn't sound very, very big, but if you think of not just 5 items in one lot, if you think of 90 items in one lot, then if you want to do a brute force approach to that, you have to think of checking 1.48 times 10 to the power of 138 combinations. So that's a real compute challenge that is to be addressed, and therefore the idea was, that's a good use case that we can apply to the digital annealer. And when we took these 90 parts and we developed a solution for that, it came to less than half a second for the calculation to be done. So that was a first use case. Why did we decide for that use case? Because that was a very good entry point, because in T-Labs, there was a lot of knowledge, a lot of pre-work available. So we could start immediately with a proof of concept, proof of value, and we could easily exchange all the information without doing a lot of pre-work. And the first step is very important, to get familiar, to know each other, and to understand the solution. So that was an excellent starting point for working together. And as I said, we might have to adjust direction. So that's a nice case. But with the knowledge that we gained jointly in that project, we started to think on what is to be done next. Are there other cases that we can make use of the technology? And this is where T-Labs came into play, because they engage in a lot of industries and use cases. And then I would like to hand over to Oliver now, so that he can explain what was done then from a T-Labs perspective. Oliver, over to you.
Yes, thank you. So you already explained the first step of the journey, and we continued from there. So we shifted our perspective to other parts, to other domains, and also took a more internal perspective. Yeah, what is happening in our own organization, and we pretty quickly then arrived at the domain of the mobile networks. That is what DT is doing, and there's various tasks, planning tasks that are also quite hard problems. So what guided our search there? That is, I think that's interesting. Because with the information we gathered from the first project, we already had some good guidance to go to the next step. So of course you have a much better feeling about problem sizes. Yeah, what can we actually fit to a digital annealer, or to maybe the next generation of an annealer. We maybe have to cut the problem, simplify it, but that already gives guidance, yeah, where you want to go, and maybe where you don't want to go because it's too big. Then, of course, the dynamics of the problem are very interesting. So, do you need an optimal solution once a year, or do you need it maybe on a daily basis? This is also quite an important input, because if you need it more often, then of course having a very fast computational device, that's really of an advantage. Delay requirements is also a factor. So how quickly do you need it? Yeah, maybe you can wait a day and you're happy with what you're doing now, but maybe it would be great to have it instantly, yeah, or really fast. And last but not least, it's also about an integration ability of a new technology, such as a digital annealer, because in the status quo, what you're typically doing now, you are already solving problems. If you run an operation, then you probably already have a software landscape, a tool landscape with tools that are already integrated into each other and working smoothly, yeah, to have a good workflow. And if you will change that, is that a good time? Yeah, maybe some software has been rolled out. It's maybe not a good time, but maybe you have a stable environment and know exactly where you could exchange something, yeah, and put the annealer at that point. So this is also important when you're looking for something very adequate to do your benchmark. So what is also maybe worth mentioning here is that even being from R&D, it doesn't mean that we are experts in every domain. So the exchange with the domain experts, so here in this case would be the mobile planners, it's very important. And so we don't want to be too invasive, because they all have day jobs. But if we keep that to a minimum, then that's a very fruitful exchange. At that opportunity, we can evangelize the optionality of new technologies, which can create also excitement, yeah, in the domains. And what's really important is that we can discuss alternative problem framings. So just thinking about it in a quantum way, so to say, thinking about problems globally, very different from what the day job usually requires. That's something that's a great opportunity, because this really sparks the discussion, and yeah, in this case also leads to new ways of thinking and solving things and approaching the problem just by framing it differently. So just some points on the characteristics here. Just think about the various sites, yeah, of a mobile network. There's tens of thousands of them in Germany. You have other dimensions as the height of these antennas. There's frequencies to assign. You maybe have an antenna tilt. You have a direction. You have a landscape, yeah, in 3D, like hills, buildings. And in the end, you want to have, of course, minimal interference. That's the big problem, yeah. If you have these radio waves all over the place, but you also want to have coverage. So you have a very nice multidimensional combinatorial optimization problem, various actually, and with each new radio access technology, these things become actually a little bit more complex. Yeah, the world is not getting easier. So this is a great playing field for doing this with Fujitsu and approaching optional computation. Okay, then I would go to the next slide. And so what has been the outcome so far? So yeah, to pour some water into the wine, yeah, it was not superior now in the initial case, but it's a big but. We have learned many more things along the way now in this second step. So the potentials are not maximized in these proof of concepts, because you can always optimize code, yeah, for the if you load the data and how you build the QBO. So these kind of points can still be made production ready. We've learned about the goals and how well they fit to an annealer, and the general strength of the annealer with regard to certain goals, but also that the perspective of the annealer is that it's the globality. Yeah, so in many cases, problems are being chunked up, divided, yeah, to conquer the problem, and people stop thinking about, well, it's actually we have one global thing here to look at, and using the annealer brings back that perspective and that possibility. And what also came up was that being able to generate many very good solutions very quickly, and combine that with the human experience, in this case here with what the mobile planners have, this is always very interesting, yeah, because actually having very quickly, let's say 40 solutions, and then a human being, an expert planner, can then scan that. Yeah, that's actually very doable and even desired. Yeah, because as an expert, he can do that quickly. He just doesn't want to wait, yeah, for these solutions. So if they could be there instantly, and this is the hard computational problem, that would still that would really be of a benefit. And so this combination of the people and machines, yeah, this is, I think, a very good example how, yeah, the best of both worlds can come together to generate something more powerful. So we do stay curious. We have projects running right now as we speak for the rest of the year, because because of these points I mentioned, they are interesting, and we are exploring them because we think that this is coming. Yeah. So, handing it back to you, Georg.
Thank you, Oliver. Sorry. So for the next step, and as Oliver mentioned, we have a lot of further projects in the pipeline. But the next step, of course, is to target for productive use, and that's not that easy, because thinking back to the problem with the headlamps, so okay, we can solve the technical and mathematical part within half a second. But the question would be, is my production line prepared to reorder lot sizes of 90 pieces, 2 times 90 pieces, in order to reduce the crap and so on. So the processes in real world have to be adjusted, and they have to be prepared for the deployment of this kind of optimization services. And that is the very reason why we have to start thinking about these topics now, and why we should make use of, for example, quantum-inspired optimization services to tackle real problems and to prepare for the process alignments in real world, which will be required as soon as even more compute power and solving capabilities will become available with quantum advantages or progress in quantum technology. Of course, our digital annealer is evolving too, and we're discussing, as Oliver already mentioned, a lot of other use cases here. So our message to you is to go ahead, start with the first step. We have those small steps. We have this 3-step approach, and we try to be focused on the quick business advantage that we want to achieve with deploying these technologies. We have more use cases in our booth, in our virtual booth here. And that's our message for today. I'm handing over to Oliver back for some last comments.
Well, yeah, thank you very much. I think it's a great cooperation on this, bringing these the domain and the problems together with this new powerful technology option. And yeah, we are very excited what the future will bring.
Thank you. Back to you, Kim.
Thank you, Oliver. Thank you, Georg, for this really insightful presentation and for really showing how collaboration can look like, because that's what this conference is all about, to share use cases and share stories of how successful collaboration can enrich the quantum community and the wider and broader world.